Hello students, today within force and pressure chapter we will start pressure. So what is pressure? Pressure is the thrust exerted on the object or on a body per unit area. It means you want to know first what is the thrust. Thrust is actually it is the force. We know that force can be applied on a body or on a surface in any direction. If the force is applied on the surface perpendicularly, then that force is known as the thrust. So perpendicular force applied on the surface, then that force is known as the thrust. So thrust is one kind of force, and thrust per unit area, that is known as the pressure. So pressure is equal to what? Force divided by area. And force, instead of force, what I have to write here? I have to write here thrust. T-H-U-R-S-T. Thrust divided by area. The unit of the thrust is same as that of the force, that is Newton. And unit of area is meter square. So Newton per meter square is equal to 1 Pascal. So 1 Pascal, what is 1 Pascal? That is the SI unit of the pressure. When 1 Newton force is applied on an area of 1 meter square, then whatever the pressure is produced, that is known as the Pascal. It means pressure depends on two factors. First, on the applied perpendicular force applied, and second, it depends on area of cross section. More the force, more will be the pressure produced, and more the area of the cross section, less will be the pressure. More the area of cross section, less will be the pressure. The effect of thrust depends on the area of surface on which it is acts. Smaller the area of surface on which the thrust acts, larger is its effect. Larger is its effect means larger pressure will be produced. For example, suppose a boy is standing on the loose sand, then his feet will sink deeply into the sand. But when the same boy lie down on the sand, then his body will not sink as much as it was sunk before into the sand. In both the cases, the thrust exerted were the same. Both the cases, since the same boy was there, once he was in the standing position, other time he was in the sleeping position. So the thrust exerted is same, means the force exerted is the same. But the reason, the difference, that when he was standing at that time, his feet sink deeply into the sand, and when he was in the sleeping mode at that time, when he was lie down on the sand, at that time he does not sink much into the sand. The reason was that in the first case, the area of contact was the less. The area of contact with the surface was the less. But in the second case, area of contact of the whole body was there with the surface, means area of contact was more. Since in the first case, the smaller area was acting, the thrust was acting on the smaller area. So the boy will sink more, and when he lies down at that time, the same thrust act on a larger area, so he sink less in the sand. Same thing is observed when, if you hammer a nail holding it with it's flattened and resting on a wooden block, you will find it difficult to get the nail into the block. But if you hammer the nail holding its sharp end resting on the block, the nail penetrates into the block easily. The reason is that, what is the reason behind? The same, that when thrust acting on the flattened end, the effect of the thrust is small, but when the same thrust act on the sharp end, the effect of the thrust is more. So the effect of thrust is, it means pressure is what? Pressure is the effect of thrust expressed in terms of a quantity. More the effect of a given thrust on a surface, then we can say that thrust exert more pressure on the surface, and less the effect of the thrust on a surface, we say that the thrust exert a less pressure on the surface. So pressure is what? Pressure is force per unit area. Pressure is equal to force per unit area. And the factors which affect the pressure, that is area of the surface on which thrust acts, and second on the magnitude of the thrust acting on the surface. Now for example, again I am giving you more examples. Suppose you have a brick. When you will keep the brick, one brick uh, along its that suppose this is a brick is there, and this surface, if this surface is kept on the sand, but other next case, if this surface, that this one surface, this area of cross section is more if this surface is kept on the sand. In this way, when it is kept on the sand, in this case it will sink more, and when in a reverse way if I will keep, then it will sink, the sinking will be less, like when it is in this way. If this part is there, then the sinking will be less. It means it depends on the area of the contact. And here if I will keep two bricks, and here if I will keep one brick, two bricks, the thrust exerted will be more. So in that case it will sink more. So the pressure exerted will be more. Now we will discuss about some of the examples in our daily life. So decrease in area, where we will discuss that decrease in area increases the pressure. Just now I have given you an example of the nail, that or a board pin. If the end is, you know that all the board pin or the awl pin or the nail, sharp pointed ends are there, so they can prick easily within the board or within the wall. Next, the cutting tools, whether it is a scissor or the knife, you will observe that the end is very sharp. Both the side inclined planes are there, so it will become very sharp. When sharp, then the area of cross section is less. Area of cross section when it is less, then easily you can cut, because the pressure exerted will be more and you will require the less force. With the less force you can exert more pressure. Now pointed heels of footwear exert more pressure on the ground than the regular flat heels. Therefore, suppose a lady with pointed heels sandals find it difficult to walk on a muddy road than on a tarred road. Another example which I will give, day-to-day life, where due to increase in surface area, the pressure is decreased. You have noticed that heavy trucks have 6 to 8 tires instead of conventional 4 tires, because number of tires increases, means the area of contact of this truck increases with the surface. More the number of tires are used to increase the area of contact and thereby reduce the pressure on the ground. Now a camel can more convenient on sand as compared to a horse. Why? Because the reason is that the camel has broader feet than that of a horse. So the broader feet of the camel provide lesser pressure on the sand and it becomes easier for the camel to walk. But in case of the horse, the area of the feet is less, and due to which the pressure is more, and hence the feet show a tendency to sink inside the sand and making it difficult for him to walk. Skiers, you have seen that they use long flat skis to slide over the snow. The larger the area of the contact, since the skis are there, it means the area of contact that is larger, so the lesser is the pressure on the snow, and this helps the skier to slide comfortably without sinking in the snow. Army tanks. Have you ever observed army tanks within on the TV channel, on the TV? So are usually have very broad, and usually having very broad means actually they have this type of conveyor belts like structures are there. So they exert large pressure on the ground if they move on wheels. Hence they are made to move over a broad steel track called caterpillar wheels of the tank. So when these are used, so they increase the surface area and thus reduce the pressure on the flat surface or on the ground, hence avoid sinking of these wheels into the ground. Foundation of the buildings are kept wide so that the weight of the building may act on larger area. As a result, it will exert less pressure on the ground and this avoids sinking of the building into the earth. A porter, you have noticed that always they wear the turban on his head when he has to carry heavy loads. This helps him in increasing the area of contact of the load with the head, so they can reduce the pressure of the load on the head. School bags or shopping bags have broad straps. The straps are very broad, or the belts, so that the area of contact increases and thus the pressure on the hand or the soldiers is reduced. Wide wooden sleepers are placed below the railway tracks, so that you have noticed that the wooden sleepers are placed below the railway tracks so that the pressure exerted by the rail on the ground becomes less. So in this way, by increasing the area of contact, the pressure is reduced, and by decreasing the area of contact or by sharpening, the area of contact is reduced. Uh, Now we will do the numericals related to the pressure. So here it is, a force of 16 Newton acts on an area of 60 centimeters square. What is the magnitude of pressure? Force is given to you, area is given to you, you have to find out the pressure. We know that pressure is equal to thrust divided by area. So pressure is equal to thrust divided by area. Now thrust is given to you, that is 16 Newton, and area is given to you 50 centimeter square. But Newton is SI unit and centimeter square is not the SI unit. We have to convert it into the meter square first. So 16 Newton divided by 50, and centimeter square means 100 into 100. Then it will be converted into the meter square. So that is equal to 16 into this 10,000 divided by 50 Newton per meter square here, that is actually the Pascal. So equal to, cancel it, this much Pascal. Okay. Next one is a force F acts on an area of 600 centimeters square. Area is given to you here, and then produces a pressure of 12,500 Pascal. Then calculate the magnitude of force. You have to calculate the magnitude of the force. So we know that pressure is equal to force by area. Here I have to find out the F. So F is equal to P into A. So that is, P is given to you, here it is provided, P is equal to 12,500 Pascal, and then your area A is equal to 600 centimeter square, that is equal to 600 divided by 100 into 100 meter square. So this is equal to 12,500 Pascal, that is, Pascal is what? Pascal is Newton per meter square. So Newton per meter square into area is 600 divided by 10,000 meter square. Meter square cancels, two zeros cancel with this 2 0, and these 2 zeros cancel with this one. 125 into 6. So that is equal to 750. 750 Newton. 750 Newton. Now next, so here you have to find out the pressure. Pressure is equal to force by area, putting the values of the force and area. Area it is given in centimeter square, so convert it into the meter square, then calculate the pressure. In the next sum, you have to find out the force. And we know that pressure is equal to force by area, so force will be equal to pressure into area. Both I will write in the SI unit. Pressure is Pascal. Pascal is what? That is the Newton per meter square. So meter square cancel with this meter square, then multiply, you will get 750 Newton. So a force of 750 Newton acts on an area of 600 centimeter square, produces a pressure of 12,500 Pascal. Next sum is, here you have to, force is given to you, then pressure is given to you, you have to find out the area in meter square. So pressure is equal to force divided by area, you have to calculate the area, so A is equal to F divided by P. Okay. Now force is given to you 50 Newton and A pressure is 2000 Pascal. That is equal to 50 Newton and 2000 Pascal is Newton per meter square. Per meter square, that will go up, so meter square. So here it will be, here cancelled 540. So it is equal to 1 by 40 meter square, and that is equal to 4 to the 8, and then since 4 to the 8 and 4. Meter square. So in this way, with the same formula, that is pressure is equal to force by area, we can calculate whatever is asked. Whether pressure is asked, then we will write P is equal to F by A. When area is asked, I will write it F by P. And when force, then it is equal to pressure into area. Force is same as that of the thrust. Whether sometimes it will be mentioned thrust, sometimes it will be mentioned in the numerical force, but both are same. So this is all about the numericals of related to the pressure for class 8 standard.